Imagine a road as a multi-layered cake. The top layer, the one you drive on, is the asphalt or concrete pavement. But just like a cake needs a strong base, so does a road. This crucial base layer is called the subbase. It sits directly on the natural soil and provides a stable foundation for the pavement layers above. In Cambodia, building a strong and durable road starts with a well-designed and constructed stabilized subbase. This layer plays a vital role in ensuring the road can withstand heavy traffic loads and the challenging Cambodian climate. Without a stable subbase, the road will quickly deteriorate, leading to potholes, cracks, and costly repairs. A stabilized subbase is created by mixing the natural soil with stabilizing agents like cement or lime. This process improves the soil's strength, stiffness, and resistance to moisture. A well-designed and constructed stabilized subbase is essential for extending the life of the road and reducing maintenance costs. Before we can even think about building the road, we need to understand the ground it will be built on. This means figuring out the characteristics of the existing soil, the expected traffic load, and the local climate conditions. First, we investigate the soil. We need to know what type of soil it is. Is it clay, sand, or something else? How strong is it? How much water can it hold? This information helps us decide if we can use the existing soil for the subbase, or if we need to bring in different materials. Next, we consider the traffic. How many vehicles are expected to use the road each day? Are there heavy trucks or mostly cars? This will determine how strong the subbase needs to be. Finally, we can't forget about the Cambodian climate. Heavy monsoon rains can saturate the soil and weaken the subbase. We need to choose materials and construction techniques that can withstand these extreme weather conditions. Once we understand the project requirements, we can choose the best method for stabilizing the subbase. There are several options available, each with its pros and cons. One common method is cement stabilization. This involves mixing the soil with a specific amount of cement and water. The cement reacts with the soil, binding the particles together and increasing its strength. This method is cost-effective and widely used in Cambodia. Another option is lime stabilization, which is particularly effective for soils with high clay content. Lime changes the properties of the clay, making it less prone to swelling when wet. This method improves the soil's workability and reduces its plasticity. Other stabilization methods include using fly ash, bitumen, or chemical additives. The choice of the best method depends on factors like the soil type, availability of materials, and project budget. Before we finalize the mix design for the stabilized subbase, we need to conduct laboratory tests. These tests help us determine the optimal amount of stabilizer to add and ensure the final mix meets the required strength and durability standards. One essential test is the Proctor compaction test. This test helps us determine the maximum density we can achieve for the soil stabilizer mix. Achieving the proper density is crucial for ensuring the subbase's stability. Another important test is the California Bearing Ratio, CBR test. This test measures the load-bearing capacity of the stabilized soil. The CBR value helps us determine the thickness of the subbase layer required for the expected traffic load. The recipe for success mix design. With the results of the laboratory tests in hand, we can now develop the mix design for the stabilized subbase. This is like a recipe that specifies the exact proportions of each ingredient. First, we determine the gradation of the soil. This refers to the distribution of different particle sizes in the soil. We need a good balance of coarse and fine particles to achieve a dense and stable mix. Next, we calculate the amount of stabilizer required. This is based on the soil type, the desired strength, and the results of the laboratory tests. Adding too little stabilizer will result in a weak subbase, while adding too much can be uneconomical. Finally, we optimize the mix design through trial mixes and further testing. This ensures that the final mix meets all the project requirements and performs well under the expected traffic and environmental conditions. Once we have the perfect mix design, we can move on to the structural design of the subbase layer. This involves determining the thickness of the layer required to support the traffic load and distribute it evenly onto the subgrade. The thickness of the subbase depends on factors like the CBR value of the stabilized soil, the traffic load, and the strength of the subgrade. A higher CBR value allows for a thinner subbase layer, while a lower CBR value necessitates a thicker layer. Proper compaction of the subbase is crucial during construction. Compaction expels air voids from the soil stabilizer mix, increasing its density and strength. We achieve the required compaction by using specialized equipment like vibratory rollers. Cambodia's tropical climate, characterized by heavy monsoon rains, presents unique challenges for road construction. The abundance of rainfall can saturate the subbase, potentially leading to reduced strength and stability. To mitigate the impact of the monsoon season, it is crucial to incorporate drainage features into the road design. This includes installing adequate side drains, cross drains, and geotextiles to prevent water from infiltrating the subbase. Using cement or lime as stabilizers can enhance the subbase's resistance to moisture. Cement stabilization creates a more impervious layer, while lime helps control the swelling potential of clayey soils. Throughout the construction process, rigorous quality control measures are essential to ensure the stabilized subbase meets the required standards. This involves regular testing and inspection at every stage, from material selection to compaction. Inspectors check the quality of the soil and stabilizer materials, ensuring they are free from contaminants and meet the specified gradation. They also monitor the mixing process to ensure the correct proportions of each material are used. During compaction, inspectors use nuclear density gauges to verify that the subbase has achieved the required density. Any areas that do not meet the specifications are reworked and recompacted until satisfactory results are obtained. Building a durable and long-lasting road in Cambodia requires a well-designed and constructed stabilized subbase. By understanding the project requirements, selecting suitable materials and stabilization methods, conducting thorough laboratory tests, and implementing stringent quality control measures, we can create a strong foundation for the road. Careful consideration of Cambodia's unique climate, particularly the heavy monsoon rains, is crucial. Incorporating appropriate drainage features and using stabilizers that enhance moisture resistance will help ensure the subbase's long-term performance. By following these steps and adhering to best practices, we can build roads in Cambodia that can withstand the test of time and contribute to the country's economic growth and development.